let's get started. I got the signal. So hello everyone. Hope you guys have made it through the first day. And I think this is the last one or the last session, but that's okay. I'm here to talk about, as the title says here, the applicability of CXL for storage applications. A few things about me. So I'm here representing the CXL Consortium. I'm the marketing chair now. I used to be the co-chair, but the other person resigned recently to do other things. So I'm now the chair. And MWG stands for Marketing Work Group. And in my day job, I work at Intel in the product planning and the CXL initiatives group. So basically on the Xeon data center CPU. So that's my. Okay, so in today's talk, basically I'll talk about how CXL, this is a storage conference, so how CXL can help the storage cost is really in a nutshell. And I'll show you some example cases based on submissions or other presentations from our member companies, all right? So let's begin with a quick primer. I mean, this slide has been shown a few times now, thanks to the previous speakers. So I shouldn't spend too much time. As I said, she told me I only 10 minutes. But everyone here, I assume, knows what CXL is. The first two are the accelerator types. Unfortunately, there are not too many accelerator devices which are on the market today. There are a few, but they're all FPGA-based because most companies are doing some specialized accelerators that I know of. I come from Altera, and that's where their main thing is actually the accelerators, right? So they are the FPGA, they have a CXL hard IP. But today, it's more about the use case 3. And as I said to the previous speaker, I have the same animation. We'll focus on that. And the type 3 CXL device is nothing but a memory buffer. So yes, the way you can add more memory to the processor is by sticking a CXL memory card on one of the PCIe interfaces of the processor. And yes, you need this CXL to DDR protocol converter ASIC. We call it the CXL memory controller. And then you have the regular DRAM. Whether it's DDR4 or DDR5 or LPDDR, CXL is agnostic because as long as the controller can support what memory is below it. In fact, at one time, since I said I'm from Intel, we had the Optane memory, which was, as we all know, it was like a storage class memory. And even though it was much lower bandwidth, overall bandwidth compared to rest of the DRAM, we could support it. The CXL controller was going to be there natively. It was all designed. So CXL is agnostic, and that opens up a lot of opportunities, as I'll show you on the next slide. Again, all of you seen this slide before. With the introduction of CXL, now we have two more tiers, if you will, within this memory pyramid. Below the main memory, we have the CXL memory. And then below that, you can expand it even more. That means more latency, as that latency arrow shows on the right side. It's a fabric attached, meaning have more memory attached to the CXL switch. But there is one anomaly, right? As my next, the first use case I'm going to talk about, this was from Google and Meta. They actually showed this slide and they say, what's the anomaly in this picture, right? Everyone agrees on the bandwidth trend, this is all correct. Latency increases as you go down the pyramid on the right side. Bandwidth goes up on the left side. And the cost also goes down. Cost per gigabyte should also go down. But CXL memory, if you just use a memory controller and a standard DDR5, the cost is not necessarily less than, and the main memory DDR5. So they propose some ways, which I, alluded to earlier, right? By using other tricks, how we can actually reduce the cost of CXL memory. But that's one anomaly which needs to be acknowledged. But that doesn't mean any DDR5-based CXL memory modules are doomed, because in the end, it still improves performance. So a lot of people will pay for performance, so it's still okay. Even if the cost of memory, CXL memory is somewhat higher than main memory, a lot of people will take it. So here's the slide they showed, and this was in the CXL webinar last year. And their use case was simply like a Z-swap, right? How many of you are familiar with the Linux Z-swap? I mean, that technique has been around. Some people call it, I heard some today it was called something else, but I thought it was called Z-swap. Essentially, it is a swap space application. It's constantly, it's doing a telemetry on which pages are cold in the main memory and saying, okay, move them out to another tier, like they use the CXL. Normally, you put it on a hard disk drive or SSD drive. Instead, they put it on the CXL. And my analogy is like your refrigerator, right? So you have a kitchen refrigerator and then you have a garage refrigerator. So to keep the kitchen refrigerator open and roomy, you keep on moving things a little bit longer term, which you don't need, to the garage, right? So that's exactly what they're doing. And on top of that, they're using the compression technique. So because they claim the cold data on an average can compress 2:1. So before they send that cold page down to CXL memory tier, they will compress it. And then the next slide shows how they save the cost of memory. So they openly advertise that, hey, we will reuse our DDR4, the existing DDR4 DIMMs, right? So that's their way of saying, we already have those DIMMs. With the advent of Gen 5 servers, those DIMMs will be recycled. We'll instead use them here. I'm giving the details of how they plan to use that. So they can really create a CXL memory tier, which also obeys the law of cost. Like that tier has to be lower than the DRAM tier, and this is how they do it. And because it's CXL controller, it can hide the DDR4 bandwidth, even though it's less than a DDR5 bandwidth. It can manage it. So that's how they did it. And the reason I'm showing it here, because a swap space is a SSD-based application, I'm just saying how CXL is helping the cause, right? So it's applicable to the storage conference. Okay, so that's my first use case. Okay, and then I'm showing you another slide from the CXL 2.0 specification. So when we introduced that, one of the big things they introduced, and this was at behest of, I believe it was Microsoft Azure at the time, but you all know why. The original motivation was a TCO motivation of memory pooling. They are saying, hey, we'll go broke the amount of servers in our data center. If every CPU is now packed for the worst case memory usage, then we'll go broke. We are Microsoft, but it's still, right? So they claim a lot of it's not used, all that is stranded, so you're better off putting it in a pool. So that's the original idea of the pool. But as you know, later on in 3.0, the basic TCO saving idea of the memory pool. So before I go to the next thing, the concept is any host shown here in 2.0 could only access or get a private copy of whatever extra memory it needs at runtime from this pool, right? Now, if you can also do sharing, now this TCO play goes from beyond TCO to a performance play. Because something like map and reduce are all these big data applications where the host will crunch a big pile of data by first divvying it up into several pieces, and then they exchange it before they begin the reduce process, right? So that's the classic map and reduce. Now that exchange happened over Ethernet networks, more latency, more extra networks. Now with CXL memory pool, at least for a certain data set sizes, you can contain it all there, and you can pass the data by reference, thereby saving on latency and hardware, and overall it's a performance play. That's how it was proposed. But now in this day of AI, right, some of people have shown already, and I'm going to show you one other example which one of the member companies is working on using the memory pooling concept, right? And then just looking at the picture, you can think of my other comment there. Backward compatibility, the CXL switch is also, so today this company, XCon, they have this switch chip in the market, and it is backward, meaning you can put PCI devices or SSDs even over there. So one can think of other applications in this thing where you can do checkpointing or something locally within the pool, and then later on any host can access that checkpoint. So there are a lot of other things. Although till they are proven and somebody has shown a product, I don't want to just speculate, but but you can intuitively think about different applications. So this is an example which one of the companies, MemVerge, who is a CXL, they are a software company mainly. They have put out some good software for doing memory tiering initially at version 1.1, and now with 2.0 and 3.0, they have put out their Gizmo software. I'll talk about that, but they can actually enable CXL memory sharing using the CXL memory pool. So what this slide is showing is simply showing how, because they're working on this NVIDIA Dynamo and showing that how their software can be used even in the AI workloads, right? And the picture on the right is showing you the hierarchy in an AI system, right? So today is the HBM, host memory, and then below that is local SSD and then network storage. So what they are proposing, once again, after the host memory, you have local SSD, right? What if we can do a intermediate tier, and which is what they are proposing, and they're going to put out a proof of concept in the near future, where they are showing how, by using this CXL memory pool, which can now become a tier before you ferry the data over network to some other host, which Nixel or some of these other LLMD things will do, you can actually use it for storing the KV cache, KV block managers locally. And by the way, even before the memory pool, back in the direct CXL attached memory use case, few CXL companies have shown how KV cache can be used to store on the CXL memory rather than SSD on a single node and make the GPU go faster and basically stall it less. Right? So now this is showing even in the grand scale, because now everything is scaling up. That's in 2 years. It's amazing how much the AI workload complexity has gone up. Right? So that's what this slide is showing. And so that's another. Once again, CXL is here and can play a big role in even in the AI side of things, or the side of the market. And then my last example is a startup company, and their representative is here. It's called Wally Technology. What they are showing, they are aiming their product for a PCI link constrained CPUs, meaning read high-end desktops or hopefully and laptops in the future, right? So in such CPUs, unlike the big Xeons, you don't have the luxury of having 6 PCI links, right? So that today the big Xeon can say, okay, leave some PCI things for storage and networking cards or GPU. You can use the rest for CXL. Because you have 6 of them, you can definitely add CXL memory. But in a high-end desktop or a workstation class product, you don't have that luxury. So what they are proposing is, so left side graphic shows on a big Xeon how you have the luxury of both storage using pure PCI, or you can make use of it as a CXL on the left side. And then on the right side, what their device they're going to launch is showing is how you can have both storage as well as CXL memory advantage. Because now their card will host, and I have a picture of that coming up, we'll host the SSD on one side of the card, and we'll have the CXL DRAM on the upper side, right? And what they are saying is basically run NVMe or CXL, because NVMe is a PCI protocol. It can run over CXL.io, and you can do a lot of interesting things. Or part of that DRAM you could expose directly as CXL memory, not as part of the NVMe driver memory, and interleave it with the main DRAM and increase the bandwidth of your system. So all kinds of interesting applications for the HEDT, the high-end desktop and the workstation market. Right. And here's another slide on what exactly they are proposing. And they are proposing they will use LPDDR5 because lower power is key. So these are the specs, and then this is a slide they gave me, which I'm showing. And so that's, I think, pretty much it. So to summarize, right? So CXL memory, as we know, is still new, but definitely helping the storage industry here. The CXL-based applications are definitely beginning to emerge. use of CXL memory as a inbit. Basically, it's a use of CXL memory as a tier between DRAM and SSDs, right? So helps with memory capacity expansion, as we know, and helps alleviates pressure on the SSD layer for many emerging. And then, yes, as the memory pooling goes, there's a lot of excitement in the hyperscaler community as well. And then, as I said, it can also be leveraged for doing AI. So that's my talk. And
so you mentioned switch-based cooling. You didn't mention multi-headed controller cooling, smaller pools, if I may. Yeah, that is something that seems to be TCO advantage to it as well, latency advantage to it.
yes, the multi-head on the right now though, I don't know of any particular company who's going to put out a direct MHSLD. There is a switch-based company. That's why I mentioned the switch. That's what you can play with.
We contributed. Seagate contributed to OCP last year, a multi-headed appliance.
Correct. Correct. Yes.
And that just seems to be, it was a POC.
Correct.
But there could be potentially additional work towards 2.0
Yes.
basic base.
Yeah, I'm from Intel. I've talked to Mohammed, and you're not Mohammed, no? Oh, you are Mohammed? Oh, okay. See, we just talk over emails. So you flew out from Minnesota?
Well, basically, the whole team is here.
Okay, good, good. Yeah, we'll definitely. Okay, no more questions. My talk must be clear. Okay, next speaker, yeah, sure.